Why are some human populations so much taller than others? Is it just the milk they drink, or was it written in their DNA thousands of years ago? Today, we're diving into my study of 60 populations to find out how ancient male founder events still dictate who stands tallest today. Height is not just an aesthetic matter. It is a vital indicator of health, as it is critically linked to nutritional quality and overall health during adolescence. The prevalence of infectious diseases exhausts the body's growth capacity, which is why physical height has long been a subject of scientific interest. However, height is also a highly heritable trait. In other words, genes define the possibilities, while the environment determines their fulfillment. Throughout history, some nations have experienced massive turbulence in living conditions, causing historical differences in average height to fluctuate by as much as 20 centimeters. Even today, we encounter significant differences between various social groups within the same nation. For example, in our extensive study of Czech high school students conducted years ago, we found differences of 4 to 5 centimeters between social extremes. Modern GWAS, genome-wide association studies, strive to identify the genes predetermining physical stature. However, due to the significant role of the environment, this task is extremely difficult. Furthermore, height is the result of interactions between thousands of genes, making the identification of causal relationships even more complex. Early GWAS attempted to identify height genes based on differences between European populations, but it was soon discovered that population-level differences could be heavily skewed by environmental factors. Consequently, current GWAS rely mainly on individual data from the UK Biobank, a massive database of human genomes. Yet even here, we face fundamental problems. While individual data can be controlled for social status or education, the most critical environmental factors, nutrition and health during adolescence, are virtually impossible to quantify precisely. As a result, some modern studies have effectively resigned from trying to identify specific height genes, and instead attempt to estimate genetic potential based on individual differences in the proportions of autosomal ancestry components or clusters. These represent the fraction of our DNA inherited from various prehistoric populations. Since everyone has a vast number of ancestors of diverse origins in their family tree, our DNA is a mosaic of the genetic heritage of many such ancient ethnic groups. My study employed a similar methodology, but focused on the genetic averages of 60 nations across Europe, North Africa, and the Near East rather than individuals. The goal was to determine to what extent height differences between populations result from ancient genetic history. I focused on Y haplogroups, male genetic lineages based on specific mutations on the Y chromosome that are passed from father to son. Alongside this, I gathered population averages for autosomal ancestry components that have shaped the genetic history of Europeans, North Africans, and Near Easterners since the late Upper Paleolithic. The proportions of these ancestry components in individual DNA are not fixed numbers. They change based on the quantity and resolution of the analysis. On a global level, for instance, we can currently distinguish 5 to 6 main components, equivalent to continental races. But at higher resolutions, we can find dozens of additional population subgroups with isolated histories. One of the most important findings of this work is that the geographic distribution of male Y haplogroups and ancestry components shows an extremely strong correlation, reaching values as high as 0.99 in some cases. This phenomenon confirms that the formation of modern populations was fundamentally influenced by so-called founder events, situations where a small group of men in the past dramatically expanded their genetic profile at the expense of other lineages. Y haplogroups and ancestry components also correlate strongly with population averages for male height. These correlations persist even after adjusting for major external factors such as nutritional quality, infant mortality, or fertility rates. The strongest positive link with above-average height was found in haplogroup I, a legacy of Paleolithic hunter-gatherers from the so-called Villabruna cluster, associated with the epigravettian culture of the late Ice Age. Another strongly correlating male lineage is R1BU106, linked to the migrations of Yamnaya pastoralists who brought steppe ancestry from the Pontic steppes into Europe. On the opposite side of the spectrum are haplogroups associated with Near Eastern farmers, and particularly lineages E1BM123, J1, and T, which are characteristic of modern populations of the Arabian Peninsula. These results are mirrored at the autosomal level. The components most strongly correlating with height are Villabruna and Yamnaya, while the strongest negative correlate is the Natufian component from the prehistoric Levant, now typical of the Arabian Peninsula. The differences between these populations are truly staggering. In Yemen, average heights are nearly 20 centimeters shorter than in Scandinavia, the Baltic region, and the Western Balkans. While the harsh desert environment historically played a role, the genetic data confirms a lower polygenic height potential. Scientists are still uncertain whether the height of modern Europeans is more strongly conditioned by Villabruna or Yamnaya ancestry. Results vary based on the specific Gwas study and the genes allegedly associated with height. My study does not provide a definitive answer in this regard either. While the role of Yamnaya ancestry is significantly stronger, the difference nearly disappears when nutrition and infant mortality are taken into account. Villabruna ancestry is present in the gene pool of modern Europeans to a much lesser extent than Yamnaya ancestry. It survives most strongly among the current inhabitants of the Baltic region, whose male lineages from Y haplogroup I were replaced by those of Yamnaya men and later also Finn-Ugric hunter-gatherers. However, it is noteworthy that Villabruna plays a more significant role in the economically developed parts of Western Europe, where the impact of the environment is smaller than in Eastern Europe. Based on these observations, I believe that the Villabruna component is a slightly stronger predictor of stature than the Yamnaya component and acts as a differentiating factor among nations with similar proportions of Yamnaya ancestry. This can be demonstrated by comparing Germanic and originally Celtic populations of Western Europe, where we find height differences of approximately 3 centimeters. Germanic nations have similar levels of Yamnaya ancestry, but significantly more of Villabruna ancestry. Furthermore, there is no doubt that the genetic potential of Eastern European nations has not yet been fully expressed due to environmental factors. What does this mean for us? It means your height isn't just a result of what you ate as a child. It is an echo of migrations and the heritage of your ancestors from 5,000 years ago. If you are tall, there is a good chance that the blood of ancient hunter-gatherers or steppe riders who once rewrote the map of Europe flows in your veins. But here, where it gets weird, the tallest men in the world aren't in Scandinavia or the Baltic region. They're in the Dinaric Alps of the former Yugoslavia. Young men in Montenegro reach 182.9 centimeters, 6 feet. The average male height in Herzegovina is 183.4 centimeters, and men in Dalmatia are even taller with 183.7 centimeters. In addition, the height in the core area of the Dinaric Alps fluctuates steadily around 184.5 centimeters, and some urban areas in Dalmatia are already approaching a staggering average of 190 centimeters, 6 feet 3 inches. Even though this region has faced economic challenges, their genetic potential is so high it overrides suboptimal living conditions. Men in these regions carry a specific subbranch of Y haplogroup I, called ITA P37-2, which agrees with the key role of this Y haplogroup in Europe. At the autosomal level, however, we encounter a mysterious paradox. Their extraordinary height cannot be explained by either the Villabruna or the Yamnaya components. Instead, it correlates strongly and positively with the components of Near Eastern Anatolian Neolithics and Caucasus hunter-gatherers, whose relationship to physical height elsewhere in Europe is otherwise strongly negative. We will attempt to uncover this anomalous mystery in another video.